Hello students and welcome to my channel Maths Hub. So in this video, I will be talking about multiple integrals and I will focus on the topic of area of plane figures in polar coordinates, right? So I would request you to check my previous video on area of plane figures. It will help you to give an idea how we calculate areas of plane figures, right? So now let us start the concept with the help of a question. Calculate the area which is inside the cardioid and outside the circle r is equal to 2. So before I start explaining this question, we have done the concept of area as double integral ds, which is dy dx or dx dy. Now, when I convert this into polar coordinates, you have to keep the concept that how we change the variables, right? So when we change the variables, so we are working in two dimensions. So that means x and y are getting converted in terms of r and theta. So when I convert dx dy in terms of r and theta, a Jacobian is introduced and the Jacobian is r. It is not rho. You can take any abbreviation, right? You can take any variable. So it is r and dx dy gets converted to dr d theta. So this becomes the concept of area in polar coordinates. So now, when we are calculating the area which is inside the cardioid and outside the circle, again I will request you to check my videos on curve tracing. They will help you how to trace these curves, right? Because if you're unaware of tracing these curves, then these questions seem to be very, very difficult, right? So now when it is a cardioid, you can see that this is the shape of the cardioid, r equal to 2 times 1 plus cos theta, and it is the circle r is equal to 2 is a circle passing through the origin and the radius is 2, right? Now how to calculate the area? It is inside the cardioid and outside the circle. So you can see the shaded portion, right? So we can calculate the area as, now you can see that the area is symmetrical about theta equal to 0 plane, right? So I can calculate the area in the first coordinate, that means between theta equal to 0 and theta equal to pi by 2, and I can multiply it with 2. So I'll calculate in a similar way. I'll calculate the area in the first quadrant. So area is rho r dr d theta. Now what is the radius? Let's take a ray. Where is the ray entering this region? At the equation of the circle, that is r is equal to 2. And where is it exiting the region? It is exiting at the equation of the cardioid. That is 2 times 1 plus cos theta. And now where is theta ranging from? Theta is ranging from 0 to pi by 2. So that becomes the limits of theta, right? So let us try to evaluate it. So this is 0 to pi by 2. Integration of r is r square by 2. Limits from 2 to 2 into 1 plus cos theta. And we have d theta here. So this 2 will go out and get cancelled. We will have 0 to pi by 2. So I will get 4 times 1 plus cos theta whole square minus 4 d theta. Let us solve this. I can take out 4 common. 0 to pi by 2, 1 plus cos square theta plus 2 cos theta minus 1 d theta. So 1 gets cancelled. We have 4 times 0 to pi by 2 cos square theta plus 2 cos theta d theta. And now I can use the reduction formula in both the expressions of cos square and cos. For cos square theta, the expression becomes, we will subtract all the odd powers. So 2 minus 1 is 1 divided by 2 into pi by 2 because 2 is odd. Yeah, 2 is even, sorry. And we have 2 times integration of cos theta is basically sine theta, limits from 0 to pi by 2, right? So that becomes 4 times pi by 4 plus 2 times sine pi by 2 is 1, sine 0 is 0. So that is 4 into pi by 4 plus 2 So where you multiply with 4, you'll get pi plus 8, right? So this becomes the answer for the area. I hope it is understandable, right? So let's move to another question. We will be calculating the area of a loop of the curve r equal to a sine 2 theta. Again, I would request you to check my videos on curve tracing. I've done a full video on r equal to a sine 2 theta types. So these are types of rows. When n is odd, it will have double the number of leaves in it, right? So when I trace this curve, it is a curve in this form. This radius is a, right? And now it is to calculate the area of a loop. So we will try to calculate the area of one loop of this curve. So again, area is double integral r dr d theta. So the radius is 0 to a sine 2 theta. You can see it very clearly. And the limits of theta is from 0 to pi by 2, right? So this is 0 to pi by 2, r square by 2, 0 to a sine 2 theta d theta. 1 by 2 can be taken out common. 0 to pi by 2. We will have a square sine square 2 theta minus 0. So that will become 0 only. So I can take out a square common. A square by 2. Sine square 2 theta, how can I express this? I can write it as 1 minus cos 4 theta by 2 d theta, right? So now this is a square by 4. 2 is taken out. Integration of 1 is theta. Integration of cos 4 theta is sine 4 theta by 4. Limits from 0 to pi by 2. So that is a square by 4. Theta will become pi by 2 minus 1 by 4. Sine 4 into pi by 2 is sine 2 pi, which is 0, minus sine 0 is also 0. So that becomes a square pi by 8, right? So I hope this question is also clear. Okay. So now to try these exercises, find the entire area bounded by the lemniscate, rho square equal to a square cos 2 theta. Do let me know the answer in the comment section. And I've also given you the answer here. So if you are facing any doubts anywhere, do let me know in the comment section, right? Okay. And do try this question also. Find the area of the cardioid r equal to a times 1 plus cos theta. And the answer you can check it as 3 pi a square by 2, right? So if you have any doubt, do let me know in the comment section. I'll do reply. And if you like the video, do hit the like button. And if you haven't subscribed my channel, do subscribe my channel to get the latest updated video. Thank you so much and have a nice day. Believe in yourself. You can definitely do it.